Okay, good morning to all. Last class we discussed about first law of thermodynamics for a closed system undergoing a cyclic operation. With the experimental evidence also we discussed Joule's experiment. The summation of in cyclic operation, the summation of all heat interactions is directly proportional to summation of all work interactions. There is no accumulation of energy inside the system. Okay. Today's class will discuss about first law of thermodynamics for a closed system undergoing individual process. For the state change, individual process, and first law of thermodynamics for isolated systems. So closed system we will complete, and then after we will discuss about isolated system. Next, third topic, perpetual motion mission of first kind. The perpetual motion mission of first kind, it's a violation of first law of thermodynamics. How they violated, we will discuss the point. Suppose we considered a closed system. Let's say just example, piston cylinder arrangement. Three walls are fixed. One wall is moving while this piston and the cylinder is filled with some fluid having the initial position, initial stage P1, V1. Because I want to represent the condition of the system. State means condition of the system. At least we required two independent intensive properties are required. The two independent intensive properties for describing the state I consider pressure, initial pressure and initial volume. Next, once I supplied heat, the fluid will absorb the heat and expansion because there is no mass flow rate. Controlled mass, closed system is controlled mass. The expansion of the fluid will take place. How it will expand? Only the piston, the only moving boundary only want to change in volume. Then it is based on the heat supply, it will move to the second position. At that condition again second state P2, P2. Okay. So in this operation, individual process closed system, what we did? We supplied heat and we produced work. Load into displacement, some displacement is there, some force is applied, so automatically force into displacement, some work done. But whatever the heat we supplied, total will convert as a work, practically not possible. Some accumulation of the energy will take place. That accumulation may be enhancement of internal energy, may be enhancement of potential energy, may be enhancement of kinetic energy, or may be enhancement of chemical energy in molecule level. So initially that have the board, the system have some energy. By this operation, the change in energy, net rise. So heat supply, suppose you see heat supply minus work done equal to change in energy. Here we are not giving absolute energy. We don't know absolute energy. But some change will occur. In closed system, individual process, we are supplying heat. Thermodynamics itself, we are supplying heat. Heat to power, that's all. So energy in means always heat supply. We are supplying the heat and it is producing some work. In this process, individual process, some accumulation of energy will take place. The accumulation means how we are measuring the change in energy of the system. Change in energy I already mentioned. It may be internal energy, it may be potential energy, it may be kinetic energy, it may be chemical energy in molecule level. System is combination of molecules only. Okay, we wrote the equation. This heat we know it is a path function. Work we know it is also path function. Initially nothing is there. While you are performing something, then only we can measure accumulation of work, accumulation of heat transfer. Okay, so the difference of two path functions is a point function or path function? Is the first question. The change in energy is path function or point function? It is very important. So first we will derive the equation. Energy, point function means it is a property. You know, the characteristic, measurable characteristic for describing the condition of the system. These all are point functions. It is not depend on the path. I already discussed in first unit. So suppose one cyclic operation I assume from 1 to 2 I moved in path A. From 2 to 1 I moved in path B. 1 to 2 I moved in path A, and 2 to 1 I moved in path B. So two paths. So we will write the equation. Cyclic operation we know summation of all heat interactions. So path A heat supply, path B heat supply equal to path A work done and path B work done. This is the first one. Summation of in cyclic operation, summation of all heat interactions equal to summation of all work interactions. Individual process. Heat supply minus work done equal to change in energy. Heat supply minus work done equal to change in energy in path A and path B. Then you add 2 and 3. Summation of all heat interactions minus summation of all work interactions equal to change in energy of path A, change in energy of the path B. Then we know in cyclic operation these are equal. Then finally we will get change in energy of A plus change in energy of B equal to 0. It means path A and path B. So finally change in energy of A equal to change in energy of B. Sign only changing because the direction is changing. One is positive, another is negative. Means magnitude is not changed. So change in energy is a point function, not path function. Don't confuse. One path function minus another path function. There is no necessity to get one more path function. Heat and work are path functions, but change in energy is a point function. It is a property. You see, suppose you select path C also. In this direction also you will get same one. Same method you can do. So finally, you can write the equation. I already mentioned. Path function means indefinite dou. We are using small quantum. That means addition of the heat. Dou Q minus dou W equal to change in energy. dE. You can write directly the change in energy D. But you can't write dQ and dW. These two are path functions, not a point function. So the final equation of first law of thermodynamics, closed system undergoing a process, individual process. The heat supply minus work done equal to change in energy. This change in energy, mass is not moving, so there is no velocity, so there is no kinetic energy in the coming to place. There is no elevation difference also. Then there is no potential energy. We are not doing any chemical reactions, only we are supplying heat. Then by supply of heat, majority internal energy only will change by from the Joule's experiment also. Internal energy is a function of temperature. How the temperature is rising? By supply of the heat only. So instead of this kinetic energy, potential and chemical energy, you can write internal energy du. So dou Q minus dou W equal to du, or dou Q equal to du plus dou W or dou Q. Dou W for closed system we already derived PD. Okay. Next, from the Joule's experiment I already mentioned change internal energy is a function of temperature. So MCP du equal to MCV dt, change in temperature. Okay. So that is the first law equation. Dou Q equal to MCV delta T plus PD. The heat supply equal to change in internal energy MCV, specified constant volume process, MCV delta T plus closed system work done equal to PdV. Based on that equation only we are deriving the heat transfer equations in different process in next class. Okay, it's clear. So Q minus W equal to change in energy. First law of thermodynamics for closed system. Coming to the first law of thermodynamics for isolated system. In isolated system statement itself, neither energy nor mass cross the boundary. Okay. So neither energy nor mass cross the boundary means heat interactions are zero, work interactions also zero. Then the change in energy, heat supply minus work done equal to change in energy. Then change in energy is 0. If change in energy is 0 means energy is constant. The first law of thermodynamics for isolated system, energy of the system is constant. That's all. The energy of the system is constant means it's the first law of thermodynamics for isolated system. Next, we'll discuss about perpetual motion machine of first kind. Perpetual motion machine means it's a violation of law of thermodynamics. One means violation of law of thermodynamics 1, and 2 means violation of law of thermodynamics 2. What happened? Thermodynamics not emerged as a science because these are the statements and observations. One more scientist group, they approached government, acquired the funds. We will prove we can violate first law of thermodynamics. That's the statement. So they constructed engine by funds acquiring from the government body, and they are planning to run the engine, but the engine practically not feasible. Finally, they failed to prove violation of first law of thermodynamics because any statement is not emerged as a science. At that time, automatically opposite groups also will come into the picture. They are trying to disagree the statement. What is their construction of engine? So in a examination, generally in general examinations, they may ask detailed explanation of perpetual motion machine of one. First, construction. They consider Rankine cycle engine only. This is the father of thermodynamics, Rankine. Steam power plants at present in India itself 2,80,000 megawatt capacity power plants are running. Okay, all are based on Rankine cycle only. So we are using pump to raise the pressure of the liquid water to the boiler pressure. From condenser pressure to the boiler pressure, we are using pump. So liquid pumping from condenser pressure to boiler pressure. In the boiler, we are supplying heat. This liquid will convert as a steam. That steam we are expanding in turbine and we are producing rotation of the shaft. There is a mechanical work. Rotation of shaft we are producing, and that rotation of shaft connected to generator we are producing the electrical energy for easy transmission and distribution purpose. Because mechanical energy we can't transfer easily. Electrical energy we can transfer because we are creating potential difference, free of electron movement will take place. It is easy to transfer the energy. And then whatever the expanded up to condenser pressure, this steam, low pressure steam rejecting heat at condenser, again the liquid we are pumping. If we are not rejected the heat means whatever the energy we extracted while in expansion, same mechanical energy is required to pump from the condenser pressure to the boiler pressure. So for this we are rejecting the heat. This is the Rankine cycle. So this team, what they did, they are not changing Rankine cycle, but they assumed one point. Instead of external heat supply by the boiler or in boiler by coal combustion or fossil fuels or solar energy or nuclear energy, some method we are supplying the heat. Instead of that, they proposed electrical heaters. Just they proposed electrical resistance heaters. So where we are supplying the energy? From the generator only. Part of electrical energy in generator, part of electrical energy whatever it is generating, it is extracting for heat supply in boiler. Remaining will distribute to the transmission and distribution lines. This is their proposal. But initially running of the plant, initially for getting steady state condition, we will give energy from the external source by coal or fossil fuel or nuclear. After system is reaching the steady state condition, then we will stop the external heat supply and simply we are extracting the electrical energy and we are running the power plant. Means finally you can see in this proposal, after reaching the engine in steady state condition, there is no energy input. So whatever the energy we are generating, part of the energy we are taking for heat supply and remaining we are giving distribution. If this facility is available, then automatically why we want to construct this many power plants? So what is the flaw? First flaw. Where is the energy input? Law of conservation of energy or whatever the equations we developed. Heat supply, energy in equal to energy out, or energy in minus energy out equal to change in energy. In cyclic operation, energy in equal to energy out. That's all. First law of thermodynamics means. But here there is no energy in. Without energy input, only we are getting output. Without energy input, only they are getting energy output, work output and heat output. How it is practically possible? Because in the universe, how much you are giving, on that you can generate something. Some accumulation will take place. If honestly we are doing 100%, we can transfer. More than that, it is practically not possible. It's a violation of first law of thermodynamics. They are unable to run the engine because without energy input, how the engine will run? We are supplying heat and producing electrical energy with some efficiency. So this is the major flaw. They tried, I think 10 years they worked on the engine. They are unable to prove. That's why whenever we are dealing with thermodynamics, first we will discuss about perpetual motion, which happens. Violation of first law of thermodynamics, practically not possible. I want to design any engine. It first want to satisfy first law of thermodynamics. If it is not satisfied, then drop the proposal. Without input, producing output, practically not possible. After 10 years, maybe they agreed, but in all thermodynamics lectures, compulsory we are explaining this. I think with this today's class I am ending. Tomorrow we will discuss about heat transfer. We will derive the heat transfer equations for different process. Thank you.